Good afternoon, everybody, and welcome to Contributed Session D on productivity. My name's Josh Martin. I'm the head of the productivity team at the ONS, and it's great to be chairing this session and welcoming you all here. We've got a very interesting and varied session on productivity. Three different presentations. One on firm level productivity estimates from Russell Black. One on global input-output table measurement from Norihiko Yamanao from the OECD, and one from myself at the end on capital utilization adjustments in productivity statistics. So each presentation is going to be about 20 minutes long, with about 10 minutes for questions after each presentation. You can enter questions in the relevant function in the platform via the chat or the Q&A function, and we'll get to those when we can. Otherwise, I will pass straight to Russell to kick us off. So Russell, over to you.
Hi. Sorry, let me start sharing my screen. Moving on. So just before I start, thanks to quite a number of people who've been involved in some of the earlier versions of this at many different stages, listed below at the Office for National Statistics. So this presentation is mainly descriptive, looking at firm level data and looking at the productivity from firm level data and how the productivity is distributed across the economy and what the changes are. The motivation for this is that at the macro level, as everyone watching is probably aware, productivity has been pancake-like for the last now longer than 10 years, a pretty sharp change in the overall product levels, so it's a lot of incentive to look at the distributions and underline the data. Another factor, just as context to have in the back of your minds, is the falling manufacturing share of employment in the UK, which in the 1970s really starts to fall down a cliff. At the same moment that productivity growth in macroeconomy starts to fall, the manufacturing share starts to stop its decline and level off. So that's context, which I'll come to a bit later. For the firm level productivity itself, there is, I'm not going to list all the amount of literature on this, it's massive. Declining firm level dynamism is a big theme in the literature. See papers they're in, Defra al. For the US, for the UK, Louis et al. Is the latest paper, and Sylvia is giving a conference elsewhere, giving a talk elsewhere at the conference on that. Another theme in the literature is differences between the distributions in terms of frontier growth, and a lot of research from the OECD looks at that across countries. In this talk, the key takeaways are, yes, declining dynamism, mixture, frontier growth. It depends how you look at it. So the data will be the annual business survey, which is the main official firm level survey collected by the Office for National Statistics, and is one of the main data sources for official economic statistics. It's a hybrid survey. It's a census and a survey. It aims to be a census of large businesses and then take a representative sample of small businesses. Because most workers work at large businesses, this means that the sample itself employs around 11 million workers on average out of about 20 to 25 million target workers. So the large firms are the bulk of that, and then a small representative sample of small firms. The name changed in 2009, and there have been predecessors which more or less operated the same way. 3 million businesses, so around 50,000 large companies, 200,000 medium companies, and then 2.5 million to 3 million small companies, as rough orders of magnitude. The coverage varies over time. For this presentation, I'm going to enforce the coverage to be the bullet points listed here. So not including finance and not including the public sector. This is a smaller chunk of the economy than the national accounts, but it's a consistent microdata source for a long stretch of time. So there are benefits to looking at this dedicated data source in sort of isolation, even if it's not the complete picture you get from GDP. For doing firm-level data analysis, we also need to make quite a bit of assumptions still. These are the main ones. Recoding, when the industrial classification system changed in 2009, 2003, we get nominal values. We'd like to have real deflators. For this presentation, I've used output deflators at the industry level. There is a long literature on, for a start, why that's not the best assumption to make, but we can't really do anything else at this point. Because we're looking at productivity, if the denominator is small and there are large errors in the denominator, it blows it up as a fraction. So outliers are very apparent in the data, and you need to truncate them. For this presentation, top and bottom 1% by year in division. And finally, in terms of weighting up to be representative of the economy, I'm using the same weights that are used in the main ABS publication. The labour data gets its own issue because the annual business survey is only collecting, just as I rattle through the rest of the data issues, financial information. Employment information is collected separately, and there are several different sources here. So I'll show you the results from several different labour sources. The main source for labour, the workforce of each firm, is the IDBR, the Interdepartmental Business Register, which is updated from tax and survey data at different points in time. I've used some of the raw survey data where it is available to get more timely estimates. It does matter, of course, because if we're trying to compare values over time, we want to have estimates of employment that match the estimates for value added as closely as possible. And as you do more complicated TFP estimation, you're putting more weight on that assumption that the timeliness is good. This is how these different measures compare. So orange is the ordinary IDBR employment, purple is adding in detail from the monthly wages and salaries survey, and blue is adding in detail from the business register employment survey, which is growing in divergence earlier in time. So labour productivity is a simple calculation because it's just dividing the GVA of the company by the workforce of the company. To note, we still want to do something to make it representative of the economy. Since we're looking at 3 million companies, we don't want to compare Tesco's to corner shops. So the labour productivity statistics will be shown weighted on an employment basis within each strata of the weighting scheme. So essentially what it shows is the productivity of the firm of the median worker, not the productivity of the median firm. And bootstrap standard errors are calculated within these strata. I can talk about the standard errors in questions. If you draw a kernel density of labour productivity distribution, this is what it looks like, and you can immediately make out anyway a lot of what's happening here. There's growth in the distribution up to 2004. It falls back with the recession, and since the recession, while there has been growth, the growth has been in the long tail of production firms that you can't really see. It's truncated on this graph. To show these statistics in more detail, if we just take two statistics, which is the mean of the distribution, which is on the x-axis, so the mean GPA per worker, and then the y-axis is the 90-50 percentile ratios. So the ratio is approximately 3.5. But over time, the ratio has grown. So we start off in 1998. The errors do encompass quite a lot of these changes. And mean productivity is not really growing that much until 2003, 2004, 2005, nor is the ratio. It's fairly stable. After 2004, we get more productivity growth, but we also get more growth in the frontier. The frontier, as a proportion of the median worker, is substantially larger, and you can see the recession quite clearly. The recession is a recession in productivity and value added. The firms are still holding on to most of their workforce. Before productivity recovers, but it still recovers at the level where the frontier is more advanced. It's mostly useful to split out manufacturing and services here, which is shown on this graph, because they're doing very different things. Manufacturing is more egalitarian than services anyway. Manufacturing has been growing very substantially over this period in productivity, apart from 2009, where it pulls back and then recovers quite quickly. Services is the remainder, and is following the same path of gradually becoming more productive, but also gradually becoming more unequal in terms of productivity, with the frontier responsible for more gross value added. You can also see the shrinking manufacturing sector as a proportion of the total workforce. The dots are proportional to the total employment in each sector. So while there is productivity growth, that's largely because the less productive parts of these blobs are being shared as jobs. The second half of this presentation is going to be on total factor productivity at the firm level. To do this, we need capital stocks. And capital stocks are accumulated at the firm level with the equation listed. We remove depreciation and we add on investment. We need to make more assumptions. Mostly this is imputing for when there is no ABS record of investment. For large companies, this is okay because the ABS is intended to be a census of large companies. And large companies do most of the investments, so we have their history of investments and we can apply the formula. For small companies, this is more of a data issue. Investment is lumpy, and then we have to sample the small company in the year that it's making an investment and hope that we get good data that's representative for other companies when we do imputation. The final issue, skipping over the long forms and short forms, is the initial capital stock value as you iterate backwards. So we need some method of assigning initial capital stocks. The method I'm proposing at the moment is a simplified capital stock with no firm level asset splits and with imputed total investment based on industry size band investment per worker from the parts of the economy which the ABS does sample, from the small sample of small firms collected. All of the other measures, we can take relevant data from the national accounts. So we'll take total industry depreciation rates from the national accounts to take account of each industry's asset mix. Some industries will have assets that depreciate faster than other industries. So for simplicity, I'm assuming that's constant throughout the industry. And initial capital stock we taken from the firm's share of national accounts. This method does end up producing estimates that are fairly similar to the national accounts if you look at the total capital stock, because the national accounts itself is very similar to what the ABS produces for the FCF, because most investment is done by large firms. The TFP methods, to show you now, I'm only going to look at a few, just for space. Either Cobb-Douglas production function or translog production function, and the production functions are estimated at the A64 level. You can go deeper, but then you have less data to estimate the function for, but it's less relevant. So there's a balance. There are many different estimation methods. Both of those papers contain many dozens of other references. The ADBEX method is the center of the literature usually, and most of the stuff now builds on that. So just a second one I'll show you then is ADBEX to the LOCA, which is an adjustment to the ADBEX ratio to better account for capital. When looking at the TFP distribution statistics, we still need some way of comparing them against each other, and my solution here is going to be to take the analog to what is done for labor productivity. So the labor productivity distribution I showed you is essentially this formula where we parameterize the Cobb-Douglas function as k to the 0 and L to the 1, and that's how we derive labor productivity. The Cobb-Douglas production function, to show comparable productivity statistics, the easiest way to do that is using the same analog. This requires you to assume that there is an industry fixed effect taken in the A hat terms. So the Cobb-Douglas total factor productivity is just going to be the term here, pi hat, which is aggregating slightly. And this graph shows what that looks like when we do the simplest possible OLS estimate of the Cobb-Douglas production function. Manufacturing, it actually makes fairly little difference. The manufacturing sector over this period has been capital neutral. It has not been investing or disinvesting capital relative to this workforce. Capital deepening and shrinking is not a factor generally. Capital has grown slightly more in total factor terms than labor productivity terms. And there's a total proportion of inputs into the economy, weighted inputs is what's now the determining the orange dots. Capital has a greater share of, manufacturing has a greater share of the economy's capital. But largely the stylized facts are the same. Productivity growth over the period, shrinking size, and the frontier is as distant as it was in 2000. The frontier, the distribution is largely the same shape. Services is where it differs. So services firms, what's special about services firms is that particular firms are binging on labor and having less growth in labor productivity even while their output is growing. In total factor productivity terms, actually these firms are being fairly capital efficient, and there is largely TFP growth that is largely even across the distribution. In bullet points. To show you the rest of the results in a large table, it's this. And you can see comparing across the methods, this largely holds out of the middle of the distribution, has pretty consistent total factor productivity growth, where it's got quite low labor productivity growth over the whole time period. The two GMM-based methods, ADBEX ratio and Cobb-Douglas, they work less well. For the different input measures that we do, they've got quite widely differing outputs. So for manufacturing, that's kind of okay. They're not differing greatly, but for the other parts of the economy, for services where the firms are less capital heavy, you really need to have the differences in capital. You need to have strong investment to get enough variation for these methods to work as well. So really the table should be grayed out here of these GMM methods are only suitable when you do have enough variation and identification in the capital data. When you do that though, they are reasonably consistent. So and reasonably consistent with the other TFP methods. So that's a positive. For reference, I've also shown you the total factor productivity statistics for all of the distribution, but the difference between services plus manufacturing relative to all is taking out all of the utilities and oil companies, which mess around the statistics a lot, by the way, which is why the 44% plus 25% doesn't average out to 15%, because the oil industry is shrinking in this period. Those are largely the points from the table. And those are the results that I'm showing you today. There's many different directions that are being investigated for future work. The next big one is dynamic distributions dynamic decompositions of investigating the extent to which the productivity growth is within firm versus between firm, and then finding more data sources to add to these other data sources. So adding in more tax data for employment, adding in tax and accounts data for capital stocks, adding in tax and accounts data for GVA to get better coverage of the firm's relative to the coverage from the ABS. The ABS is there and it's consistent, and it's 11 million workers each year. It's quite a substantial amount of data that you can tell quite a lot from, and you can still work out quite detailed capital stocks for the large companies. But to look at the dynamics comprehensively for the other half of the economy of smaller firms, you do need to have more data sources. And that's time for my presentation. Questions? Thank you for listening.
Thank you very much, Russell, and wonderfully to time, so thank you for that. We have a few questions, a couple sort of more substantive. I'm going to put the one to Brendan to Russell directly because I think it's a very quick answer. So Brendan asks, are the NACE sectors A and K, agriculture and finance, removed for the purposes of this analysis, or are they just not included in the survey?
They are A is included apart from farms, so agricultural research stations that get classified within A rather than get classified in the main R&D industry are included, but they're completely tiny. At some points, the ABS was sampling head office, umbrella corporation, holding shell companies and insurance companies. They've all been removed because they are really, really tricky and full of outliers, and I'm not even sure how you'd interpret them anyway.
Okay, thanks, Russell. So I think the answer is they're not in the data in the first place, mostly speaking.
Yes. If you were a researcher coming to the ABS, you do need to the ABS data set you'd find would be all of the data that is taken in the ABS in a particular year. You do need to look through the data to exclude these and make it consistent.
Thank you, Russell. We've got a question from Jonathan Haskell, and I'll invite Jonathan to put this to Russell directly.
Thanks very much, Russell. Jonathan Haskell speaking. Thanks for the presentation. Did I hear you right, Russell, in saying that when you did the capital stock, you were just going to do what it was just one investment, now there's one asset. Is it possible to do it, or are there just too many holes in the data for more than one asset? I don't know, ICT, non-ICT, for example, because one might imagine the composition of assets has changed a lot over the period. Thanks very much.
Definitely a good question, and definitely I skipped over this in the presentation. So to reduce respondent burden, most small companies are only asked, what is your total IT investment? Whereas large companies will be asked, please, can you split your total IT investment into investment in buildings, into machinery, and then things that are not that, like software. So you would have to do a level of imputation as well for assuming that the smaller firms are behaving like the larger firms. So some small firms do get the long form, most small firms would get the short form. So the data is there, and more detail would need to be taken to look at that. Of course, you can also look at company accounts data, and you can also look at tax data. So definitely many of the next things are to increase the detail of capital by sensibly splitting those things out.
And Russell, maybe I could ask a sort of further question to Jonathan's. Do your depreciation rates vary over time, or are they constant over time by industry?
They do vary over time because the industry capital stocks composition itself changes over time. Capital is reasonably slow moving, so it doesn't have much of an effect.
So I think that partially captures some of the asset variation, doesn't it? But not to the full degree that Jonathan was asking about. Thanks, Russell. And we've got a question from Martin Wheel.
So generally, firms do not move around the productivity distribution a lot at all. It's very close year on year, and when they are moving around the productivity distribution, it is mostly because of the mergers and acquisitions and corporate restructures, which are really a bane on this type of work, and if anything should be the thing that was top of my list of further research. So the additional work on shift share decompositions and productivity decompositions over time is getting to this then. So the contributions to productivity growth from inside firms versus from firms getting shrinking smaller and between firm growth. And mostly in the initial period, it's within firm, it's between firm, mostly in the final period, it's, across firms. Here are my annex slides, by the way, showing the actual kernel densities for manufacturing as they shrink. Versus what I showed on the chart, just if you'd like to see the shrinking of the manufacturing sector and how the shrinking of the manufacturing sector is low productivity manufacturing and a bit more vividly.
Thanks, Russell. I was going to invite Martin to put his question to you directly, but you got there before me. Martin, was there anything you wanted to add or clarify to your question?
I don't think so, thank you. That was very helpful. I must say I'm surprised that it's as stable as Russell describes, because I would have thought there'd be quite a lot of noise in the data, but perhaps not at an annual, not when you look at annual figures.
No, not annually.
Thank you.
Okay, thank you, Martin. Thank you, Russell. We've got one more question from Anthony Savaga. Anthony, do you want to put your question to Russell directly?
Hi, Josh, can you hear me? Yeah, Russell, it was a very simple question. It probably doesn't warrant a specific question like this, but I wanted to know if what's the final time period that you have, and is the ABI data available more up to date than the ARD?
So the ADBEX is a data set that lives in the secure data facilities, which is an amalgam of the ABI and the ABS, and predecessors to the ABI, in fact, and it's a bit nice that Jonathan Haskell is on the call because he has worked with that in previous years. The ABI data is fixed because the ABI finished and became the ABS in 2009, 2008. There are updates, I believe, that are due to be made to the ADBEX and moving to a new version with some very light cleaning of the ABI data. Delayed by the pandemic.
Okay, thanks very much, Russell. And we're all done on the questions, and we're beautifully to time. So I'm going to move us on to the next presentation from Norihiko Yamanao from the OECD. So Norihiko, are you there? I can see you, Norihiko, but I can't hear you at the moment.
Can you hear me?
Yes, we can.
Okay, thank you. So let me, do you see my screen as well? I think so.
Yeah, if you could make the slides full screen.
Okay.
That's perfect.
It's perfect.
Over to you.
Okay, great. Thank you. So today we are glad to introduce our recent work on the developing the global input-output database using the machine learning techniques. So we are working with the team in our team in OECD and also from Japan. So for some years, about 10 years, we've been developing the OECD inter-country input-output table, which is really a big database. It has 64 individual countries, 36 industries, and it has rows and columns in the each industry and country, so it becomes really huge table. And also we developed this for annual from 1995 to 2018. And the latest edition we will increase. It's actually 2021 edition. We have 66 economies and 45 industries. And the application of this database has been used for trading value added, which we could say it's like productivity in the exports, and the carbon footprint for the sustainable development goals indicators. And also we have some employment impact analysis as well. And those are published from our website, and we have some publication as well. So this study is trying to understand the current procedure that prepare the inter-country input system, going back to the national account and supply and use tables. And would it be better to review the process, because it takes a lot of time, so that we may lose audience in terms of the timeliness of the indicators. I know that for some countries, the supply and use tables are available up to 2018. Trade statistics could be available up to 2020, but this database can only go back like 5 years, 4 years. That's a usual process. So to do that, we may want to go a slightly different numerical approach to develop the this inter-country input system. So let me quickly go through the how we develop the inter-country ICIO. Of course, we need to collect the official data sources. That's one of our advantages, that we try to benchmark our GDP, value added, all the other variables in the input tables to the official national accounts, national IO, and SUTs. And of course, we have to do the harmonization across countries by using the same industry format, same product definitions, variations. Those should be adjusted. And then we start balancing the tables, SUTs, bilateral trade database, and try to solve the bilateral trade asymmetry issues by sector for goods and services. Finally, we can get the international use table that is connect all the countries' national accounts in the SUT format. And we develop the inter-country IO system. So I would say this is a top-down approach, because we start from like world GDP by country, and then go little by little to go down to the sectors, and then inter-industry relationship. So the target, the sales by year, it becomes larger and larger. We can start from 24 years. Then at the end, it's called more than billions of data sets we need to capture in the system. When we have the ICIO system for 24 years, 65 countries, and 45 industries. But before I move there to the next, please note that in this database, we also gather the rest of the world economies. So we try to capture the 198 countries, and also we have a slight more detailed product than 45 industries. So we have 75 products and 75 industries to balance the system. So if I put the development flow in the different format, so this is a simple flow of the development. We get the data from national account, trying to estimate the SUTs, balance the trade, and then we develop the ICIO. But in reality, we have to go really back and forth, because sometimes there are many conflicting numbers from different data sources. So that's getting really complicated. And also within the same database, we may get really conflicting numbers. Like if you think about the national account, it's a simple figures. But if we look at the individual countries, the GDP may be recorded in the calendar year, fiscal year, basic prices, producers' prices. So we have to really adjust all of the items in each stage. So we were always thinking that how can we simplify those procedures by more numerical approach rather than going back by manual procedures. So in the computer science field, there have been many discussions about how to make the complex codes into the simplified format. To interpret this in our topic, people are trying to understand the data preparation from the different perspective, like similar industry have similar structures in different countries, or if the location of the country is close, they might have the similar input structure or export structure. But it's not always true, and it's also difficult to identify what is the true numbers if the numbers are missing. For example, we can have the availability list of the national SUTs and IoTs like this. So many countries can publish supply and use tables, but not the complete input-output tables for most countries for all the annual information. So at the maximum, at the moment in 2021, we can get around 40 countries or 50 countries if the table is around 5 years ago. But most recent years, we can only get information for a few countries. So if you look from the bottom by industries, we get more disappointing numbers. For some sectors like construction, almost all countries can really publish those information. But if we want to analyze the steel industry or shipbuilding industries, then the number become really small. Then the one question we had is, should we apply the these, for example, shipbuilding industry to whole entire world? Although the shipbuilding industry's information is only published from China, Korea, Japan, or Canada, so those countries. That really makes difficult issues when we publish. So what we try to do is to check the first structure of the existing SUT structures. By looking at the simple numbers like value-added output ratios for countries, sector composition of the exports. So then if we put all countries tables, we have about 900 plus tables from the world as we develop the iShio for some years. We can have some ideas about expected range, expected variations on different measures. And it can be presented in quantile, it can be presented in simple average, medians, and also sector shares. So trying to understand the different basic statistics, we can put it in this type of format for all the different components of the supply and use tables. So this is what we call ideal SUTs and IoTs, because as I said, many countries are not able to provide all the ideal format. So we try to first rebalance what is published from the countries, including the European countries. Okay, so we simply skip the tables. This is use table, format supply tables. Then, so what is methodology here? So it's similar to the one I already mentioned, but we try to convert that manual process to more numerical approach so that we may have capacity or opportunities to make the table more timely. And of course, the most important thing is to develop the higher quality input-output system. Okay. So then we try to understand, of course, from the literature. They didn't always say this is a machine language technique, but most of the papers in the past, they have faced similar issues like what we faced. Like trying to get the data for the unavailable countries. They're trying to split the sectors and trying to use different statistics measures to fill the gaps. So yeah, so but one thing we haven't really used, or most countries, is trying to use big data from non-conventional economic statistics, or the satellite image or the pictures. Those are not really there to estimate the national account related figures. Okay. So we also try to understand from the technical side to understand how the statistics office or the intergovernment agencies are trying to apply the machine learning approach to fill the official statistics. We are trying to do something similar by looking from the first by trying to capture the outliers. If we observe a lot of zero values in the cells of the supply and use tables, if official table have a certain probability of having the missing cells or the zero values, then we may also think about the possibility of to apply the similar probability without really going through each country's specific structures. So these are the numbers we came up in our experience, and also we communicate with countries and the international organizations about to figure out the range of the input and output structures. Like what I show in here is a share of the household consumption, how much of that can be allocated to imputed rent. So those numbers are relatively, it fit into a certain range for different indicators. So for the many practitioners, they know by heart, and they also go to developing countries to help building the capacity for others to fill the gaps. But for many countries, many countries officials, they don't have this knowledge, so that I thought it's useful for us to provide this kind of a range, expected range in the different part of the SUTs. And also this range can be confirmed for the trade relationship. So to first trying to capture the outliers. So we put it into the percentile from 10, 15%, 50, it's median, and 85 and 90, and put it in range of the, for example, how much of the export can be expected if they have a certain amount of the output. So this vertical line shows the 1.0, that's 100% export. And then the horizontal shows the industry example in the world average. from agriculture to mining sectors and the food manufacturing, textiles. So they have a different average import structures. And also the average or mean is not always in the center of the available tables. So that's where I think it's useful to use this kind of a methodology, because at the moment, until we haven't used this methodology, we were basically trying to use a world reference share, which is coming from this red dot, but actually it has a larger variation, and also the variation is different by sector. So trying to understand this in a different component, and this goes to the different part of the, this goes to the annex section of the paper by export to supply ratio, import to supply ratios. It's also, we have to see this is not like a fixed, but also we might want to see the evolution over time as the globalization or fragmentation of the production process is really developed. The assembly type processing sectors may have a more export and the import penetration in the economy, but in the service economies, it shouldn't really change the structure. And also we have to think about the changes in the price or constant price. That's also not really feasible if we just stick with the official statistics, because not many countries are able to publish those constant price structures. But if we can numerically adjust using the reference price evolution, we may be able to have a better estimate. We may be able to provide better estimate if we don't have the numbers for specific years information. So it can be applied to a different part of the SUTs. Yeah. So, and also a simple ratio like government expenditure to the total supply, or gross fixed capital formation to supply, total supply. Those can be also estimated. I mean, try to capture in this way. We can see the different part, small part in the SUTs. So to summarize, we have about 20 minutes. So so I talked about the how we can review the process of estimating the ICIO structure. We still need to do data collection by hand, contacting countries and trying to harmonize the first set of the data. But we now have better tools to identify the outliers. And also we are able to split the aggregate sectors, but not by one by hand, but also with this sort of numerical approach to speed up the process. But we are still halfway to go to complete the imputation and filling the gaps to estimate the complete supply and use system in here. But also we can, I think, apply to different parts of the ICIO process by this kind of approach. So yes, I already mentioned that, and we are trying to include this approach in the next coming years. Thank you.
Thank you very much, Norihiko, and perfectly to time again, so thank you. I think you did a really good job in showing how complicated your problem is and lots of your novel solutions. So thank you for that. I thought that was very interesting. I don't think we've currently got any questions. So I'll pause a moment just to give people an opportunity. if we do get any questions come through for you, we can always return to them at the end. So at the moment, it doesn't look like there's anything there. So I suggest we bank the time and move on to the next presentation. And I think I'm passing the chair to Russell at this point. So I shall share my screen and ask Russell to keep me to time.
Okay, off you go, Josh.
Thank you. And Russell, perhaps you could tell me if you can see my screen or not.
Yeah, it's that.
Excellent. Okay. So thank you very much. I'm going to be talking about this new piece of work that we've got, looking at ways to adjust for capital utilization in productivity statistics. And this is a joint work with my co-author Kyle Jones, who's a colleague at the ONS. I should preface this by saying that these adjustments that I'm talking about here are not yet made in official statistics, in official productivity statistics. I'll show you some that are, but this is currently research work rather than anything more official than that. So a quick roadmap for this presentation. I'll talk to you about the problem that we face, some of the approaches in the literature and where they fall down, our proposed approach, and then the results from that method, and then at the end some next steps for this method. So the problem, first of all, this is the trend in economic output, GDP, in real terms, seasonally adjusted over the course of the last couple of years. And of course, I'm sure everyone would recognize this trend, the big drop in the first half of 2020 and a rebound since then. This is what hours worked in the economy looks like, following a very similar sort of pattern. This is business investment, again, quite similar with that dip in the second quarter and recovery thereafter. And this is the capital stock. No change at all, or very little. So you might immediately be able to see the problem here. If we're doing some sort of growth accounting exercise where we're trying to calculate multi-factor productivity by changes in output and accounting for those by changes in inputs, labor and capital, we've seen that output fell dramatically, labor inputs, hours worked, fell dramatically, but capital inputs did not. Now, in reality, we think that's probably not true. We think capital services probably did fall at a similar rate to output and hours worked in the economy. It's just that the way we measure it doesn't really allow for that. The way we measure capital services, for those who are not familiar, is essentially to look at the growth rate of the capital stock, which here is PS, or the productive stock, at a reasonably detailed level, at the industry and asset level. But rather than weight it together according to its share of value in the overall capital stock, we weight those growth rates together according to some user cost shares. User costs of capital are approximately equal to the rental costs of capital. In other words, they better account for the rate at which you're actually using the capital rather than its overall value. So you place a higher weight on things that depreciate quicker, like intangible assets and ICT assets, than you do on bigger and more valuable assets like buildings, which depreciate more slowly and contribute less to production in the short run. So we do that normally, but since the productive capital stock of many of these assets hasn't changed much during the pandemic, the buildings are still there, they're just not being used, the capital services measure reacts very slowly. That is, unless we adjust for the utilization of capital, and that's what the middle term is in this equation. Implicitly in our current measures and in many standard growth accounting measures, the utilization of capital is assumed to be constant, not necessarily 100% all of the time, but unchanging. So if you don't adjust for changes in utilization, then you're effectively biasing your capital services measure by the size of that change in utilization, and therefore inflicting a bias on the MFP measure by the size of that utilization change in the capital weight, which is usually about a third. So if utilization really had fallen 10%, our capital services measure would be 10% too high, and our MFP measure would be 3% too low, or thereabouts. So I'm going to explain how you could adjust for a capital utilization change in MFP statistics. First of all, this is what we have done in our official metrics. At the moment, we've made a relatively simple adjustment. We publish both the adjusted and the unadjusted data. The unadjusted data is in blue, so this is capital services without adjusting for utilization changes. That's essentially equivalent to the capital stocks line I showed you a moment ago, pretty flat. We've made an adjustment, which is the gold line here, only during 2020. Using one of the most common methods in the literature, but I'm going to go on and explain why that's suboptimal, and our approach is an improvement on that method. So a brief canter through the literature, and I won't dwell here. It's fair to say that the literature is not wholly agreed on what to do in this circumstance. Indeed, there's a fair argument to be made that you shouldn't adjust for changes in capital utilization at all. Various international guidance from the OECD, for instance, on how to measure productivity advises against making an adjustment, largely because it's difficult to do so. You could see changes in capital utilization as changes in productivity. You might view that to be the case. If there's less utilization, if there are frictions in the business process that mean that capital can't be utilized as well, you could view that as a hindrance on productivity. However, if you do want to adjust for capital utilization changes, and I think the pandemic gives us a fairly good reason why we should, then there are a number of ways that you could do it, but no overall best way recognized. Some of the methods include modeling capital utilization using other observed variables like investment and output, using other input measures like energy or materials used as a proxy for how much you're using your capital. That works reasonably well in manufacturing, where energy usage is reasonably well correlated with machine usage. But in the services economy that we live in, that's probably much less appropriate these days. You could also rely on survey-based methods. There is a survey in the UK from the CBI that asks questions on capacity utilization. But again, that probably works best in manufacturing. And it's also not clear whether the concept of capacity utilization exactly lines up with capital utilization, which is what we're trying to get at here. You can think of labor utilization as the average amount of hours worked per worker. And we're already accounting for that in our labor measures. We want something that's explicitly the capital utilization. And those survey methods are generally have small samples, incomplete coverage, and not an excellent proxy for the concept that we want. The most promising method in the literature is the second one on this list, which is using labor hours worked, which is essentially to assume that capital needs people to work it. So if people are working less, then the capital must be working less as well. Now, again, this probably works best in manufacturing, but you can see it applying across the services economy as well. But the way in which it's usually applied in the literature is to use some large aggregate of average hours worked, maybe at the whole economy level or maybe at the industry level, and applying that to all the capital in that industry. The problem with this is it doesn't reflect the heterogeneity of assets and workers and industries very effectively. You can think about in the airline industry, the hours worked of a pilot are probably a much better proxy for the hours worked of a plane than are the hours worked of the CEO of the company or someone who works in the finance department. You know, if the pilot's not working any hours, it's a fair assumption that the plane's not flying. But if the CEO is still working 40 hours, that means nothing about whether the plane is in the air or not. So we feel we need to better reflect the heterogeneity of assets and of the people who use them. Not everybody uses assets, or not everyone uses the same assets anyway. Changes in hours worked of different people should mean different things for capital utilization. And different types of capital also have a different relationship with how they're used. You know, buildings stand there and get weathered and give us protection for our capital goods and our raw materials, whether we're working in them or not, you could argue. But a machine or a vehicle is really doing nothing for you unless you're using it, working it. At the other extreme, things like copyright assets or R&D, where their value is embedded in other products, arguably bear no relationship at all to the hours worked of different people, and their utilization is more demand driven. So our approach is to better reflect the industry variation, the asset variation, and the person variation. We also adjust for a baseline. So you could think that in the sort of increasingly wealthy economy that we live in, hours worked have been slowly declining over time. That's certainly true if you go back many decades. And using the sort of standard approach in the literature, that would imply a slow, gradual decline in capital utilization as well. And I don't think that's the case. So we can adjust for a baseline, which allows us to strip out that trend effect and just get variation around the trend, which is really what we're trying to capture here. So our approach is going to try and tackle these challenges, and we're going to make three main adjustments. So the first is we're going to identify assets that actually do vary in utilization and try and apply a factor that we think approximates how much it varies in utilization. So some assets are going to be allowed to vary a lot, some are going to be allowed to vary very little, some not at all. And that's on the grounds that I was just arguing. We're also going to identify occupations that we think use different types of assets and match those occupations to each asset group. To do that, we're going to use data from the ONET database from the US, which gives us a lot of information about what different occupations actually do and what assets they use. There are some explicit questions on that, as well as a detailed understanding of the occupations and the assets, so that we can match pilots up to vehicles and the CEO and the finance department up to the IT hardware and software that they use, and not get the effects mixed up. And then we're also going to adjust for this baseline by taking the ratio between actual and usual hours worked, rather than just changes in actual hours. The labour force survey, which is going to be our main data source, asks people for both how many hours they usually work and how many they actually worked. And by taking the ratio between them, we control for the time trend. And then we're going to weight all of these things together by the user cost shares, by asset and by industry, which allows us to capture the industry variation as well, giving more weight to industries that are more capital intensive, regardless of whether they've got more people in them or not. So there's a lot of detail here on the assets and the occupations that we're going to match to them. I won't go through all of this, but let me just point out a couple of things. So firstly, the utilization of buildings. You know, everybody who works presumably works in some sort of building, be it an office, a factory, a warehouse, or something else. That is, of course, unless you work from home, in which case you're not working in a building that's owned by a business. So utilization of buildings is going to be the inverse of home working hours. So we're going to estimate home working hours, take the inverse at the industry level, and that's going to be the utilization of buildings. We're also going to split the asset class machinery and equipment into two, because machinery and equipment is a very diverse asset class. It includes everything from very specialized agricultural and manufacturing and mining machinery, all the way through to desks and chairs. And it's not fair to lump all of those in together. In fact, we couldn't find a good reason that any occupation wouldn't use some type of machinery and equipment. If you're sitting at a desk, you're using a desk. If you're in a factory, you're using something more heavy. We couldn't find a good reason to exclude anyone from this asset class. But we did think it was important to identify some occupations that work with what we call heavy machinery and equipment. And that's going to relate to that sort of higher tech stuff that I was just describing. So that's the occupations and the assets. I hope that's reasonably clear. I'm happy to provide more details in the questions. Now we're going to think about these factors that we apply to different assets that allow them to vary in their utilization more or less. And to motivate this, we can think about two main reasons why capital depreciates. There's either physical depreciation, wear and tear, which is the obvious example. So the more you drive a car, the parts slowly wear out or fur up over time. A machine with repeated use will start to wear down, or cracks will start to form, and so forth. This is physical depreciation, and it's dependent on the use of the asset. The more you use it, the quicker it depreciates. The second type of depreciation comes from obsolescence, which means that over time, an asset becomes less useful, less valuable, because of changes in the economy. Technology changes, demand changes, and so forth. In the extreme, you know, intangible assets don't have physical wear and tear. They're not physical assets. Their depreciation is due entirely to obsolescence. The fact that software depreciates is because better software comes along and replaces it. So the use of intangible assets is not a good proxy for its utilization necessarily. So we're going to use this sort of split to motivate how we allow utilization to vary for different assets. And again, this is a very complicated table that I'm not going to go through in any great detail, but just to draw out a couple of examples, the asset classes where we're going to allow most variation in utilization are transport equipment and machinery and equipment. Largely, as I was describing, the more you use them, the quicker they wear down, and clearly their utilization is linked to their physical use. Some other tangible assets are going to be somewhere in between. We're going to allow buildings to vary very little. This is a somewhat controversial choice, but the view would be that the buildings are so long lasting and provide capital services even when you're not in them, that their utilization should be allowed to vary very little. The results are quite sensitive to that assumption, and I'll show you to what degree later on. And then for most of the intangible assets, we're not going to allow their utilization to change very much at all. Software and mineral exploration to some degree, because it does depend on people using them, but largely we're not going to allow them to vary at all. Okay, and just to touch on utilization of buildings, I said it was the inverse of home working hours. So we've recently published an analysis on home working in the UK. We defined 4 groups of home workers, which were sort of different intensities of home working, and we're going to apply an assumption on what fraction of their hours are spent at home for each of those groups, and add up all of those hours, and those are going to be hours worked at home. The inverse of that is hours worked not at home, so in some sort of building somewhere by assumption. There are probably some fringe cases that we've ignored, but essentially that's going to be our utilization of buildings, and the trend in that looks exactly as you would expect it to. Okay, so to summarize then, we're going to calculate the actual to usual hours ratio for occupation groups that we've matched to assets by industry. We're going to multiply those by those asset specific factors, which is the degree to which we allow capital services actually to vary based on utilization, and then aggregate all of that by user cost shares across the assets and across the industries. Okay, let's get to some results. So if you do all of that and you aggregate all of that up to the market sector, this is the capital utilization series that you get. Now, firstly, let me say market sector, because our official multi-factor productivity estimates are only for the market sector, given that the government and other parts of the non-competitive economy acts a little differently, we restrict it to the market sector, and I've done the same thing here. So let me just describe a couple of features on this chart. Firstly, there's no impact of the 2008-09 financial crisis. That seems a bit odd. I'll get back to that at the end. There's a small upward trend in capital utilization over time. I'm not sure if I believe there should be, but I could be persuaded either way, and I'd welcome thoughts on that. Outside of COVID, and there is an obvious COVID effect here, it drops some sort of 7 to 8 percentage points at the end of the time series here, which is exactly what we'd expect, so that's reassuring. Aside from that, there's not a huge amount going on. There's a little bit of volatility at the beginning of the series, but not much thereafter. So is this what we expect? Well, here's another measure of capital utilization, and this comes from that survey source that I was describing earlier on from the CBI. This only covers manufacturing, and it's actually capacity utilization rather than capital utilization. But that aside, let's see if we can draw some similarities. Well, firstly, the CBI survey does have a 2008-09 effect, and we don't. The CBI data is also more volatile, but then it's got a small sample, so maybe that's not surprising. It's also got a different coverage. It has a much larger COVID effect, but again, it's manufacturing as opposed to the whole economy, so maybe we can accept that. And there is a slight upward trend, actually, if you ignore the COVID period, so maybe we can get behind that as well. I mentioned that at the beginning we'd made an adjustment in our official statistics. That's again here in the gold. This is the same chart as before, but I've now added 2 dotted lines to the chart. The top dotted line, the darker of the 2, which falls between the no adjustment and the current adjustment, is our full methods implementation with the factors and everything that I've described so far. So it shows a shallower fall in utilization than our current method does. However, if you don't like those factors that I applied, the 80% to transport equipment and the 20% to buildings, if you don't apply those factors and you allow everything to vary fully, then you get the dotted green line, which shows a much bigger decline in utilization. So they're all similar in shape and to some degree in magnitude, but it turns out that the exact assumptions that you make and the parameters you use do allow a little bit of sensitivity. This chart sort of persuades you that the matching of the occupations to the assets makes sense, and in the relevant industries, the hours worked are using the relevant assets that you'd expect. In the interest of time, I'm going to skip this. This is variation in that utilization adjustment, quarter-on-quarter changes by industry, and this is 64 division-level industries in the economy, so reasonably detailed. And the mean change is close to zero. It's about -8% in the second quarter of 2020, but there's a huge amount of industry variation. And even during 2020, some of the industries were actually increasing their utilization on this basis. That doesn't take into account the size of those different industries, of course, but it is a very heterogeneous picture across industries. Now, I hope since we're running good on time prior to this presentation, that Russell will indulge me in a couple more slides in a couple more minutes. We need to make some decisions. If we did want to implement this, I mean, the first question is, do we even want to adjust for capital utilization? That's the question I posed at the beginning. But if we do, we need to make a decision about how we do that. Do we only do that during the pandemic? Is that such a unique event that it warrants adjustment and no other time period does? That's what we're currently doing in our official statistics. Should we only implement this during times of crisis like the pandemic, but also the 2008-9 recession? At the moment, we've got no recession effect in our measures, but if there was one, is that what we should be doing? Should we be leaving it flat in all other periods and just adjusting in times of crisis? Or should we be implementing across the full time series? Obviously, that's more internally consistent, but it does potentially add more noise to the MFP data rather than adding intelligence. You saw there's a little bit of volatility on another otherwise pretty flat trend. So does that really help? Let me come back to this question of why there's no impact in the 2008-9 recession. This is actual and usual hours in manufacturing, actual hours in the blue and usual hours in the gold solid line. And you can see the reason that there's no utilization change in 2008-9 is because actual and usual hours both respond symmetrically. So the ratio between them doesn't change. And of course, since we're using the ratio between them as our baseline and as our proxy for utilization, that means we get no utilization adjustments. The same thing is true of the economy, although the lines are going in the other direction. So we think the problem here is that we're allowing the baseline to adjust too quickly. In reality, businesses probably take longer to react to the situation, to staff that have been laid off or made redundant or retired or for whatever other reason are unavailable to work. And our baseline of usual hours should adjust more slowly. And the dotted lines are just sort of hypothetical, smoothed series for that. So we're thinking about how we can adjust that baseline to be slower moving. And a couple of approaches that we're exploring. Firstly, one is to add the usual hours of people who've just left their job back into the baseline. So assume that it takes a quarter for a business to sort of react, change their expectations. And so anyone who's just left a job should be effectively added back into the baseline. That would create a bit of a recession effect. We could apply some sort of smoother to usual hours, maybe to actual hours as well, to get rid of some of the volatility, or apply some sort of lagging or something. We're still working on the methods there. And next steps for us after fixing that is to hopefully get this discussion published as an ESCoE discussion paper. We had one round of really helpful comments from a reviewer, and we'll be resubmitting quite soon. So that's everything. I'm sorry for running over, and I'm happy to take your questions. Thank you.
Thank you very much, Josh. So first question is from Narihiko, if you unmute and ask.
Yeah, thank you. Sorry for not able to put the question in the Q&A. So my question is, what is the suggested statistics feasible frequency data? Can you able to capture the monthly rather than quarterly? And another question is, I understand it's good to adjust utilization to measure the productivity, but we also need to have a stable GDP and the future GDP particularly. So is that going to change the future path of the depreciation path after a couple of years from now if you really change the patterns now? Thanks.
Yeah, thanks, Noriko. I skipped over what data we were actually using. So let me say that briefly. We're using the labour force survey primarily, and some other bits of the growth accounting framework to allow us to aggregate these things together. The labour force survey is a rolling survey. We've done it quarterly in line with our productivity statistics. You could, in theory, do it on a monthly or rolling 3-monthly basis. The quality of the data is likely to weaken the further you go. But I think, you know, we could produce these on a quarterly frequency in line with the timeline of our productivity statistics, and that for us is the priority. Should this, you know, make any effect on depreciation? And I think Rachel in the Q&A has got a similar question, but I'll address that again later. Yes, potentially. You could argue that when usage is higher, depreciation should also be higher. That's one of the motivations behind the approach. So if, you know, everyone's working from home and not using their office, does that mean the office depreciates more slowly? I think you'd have to take it on quite a case-by-case basis, but you could certainly see a link between utilization and depreciation, and sort of the other way around as well. We've considered that a little in the paper, but I think there'd be more to do to really parameterize that.
Thank you. Ben, if you can ask your question.
Sure, yeah. I was just wondering about how the firm's asset allocation has changed during the pandemic and how that will affect the headline figures, just in terms of more PPE or less office space. Thanks.
Thanks, Ben, and it's good to hear from you. Good to see you. So I think this is a question about investment and also capital scrappage. It's clear that businesses are investing in some things that they didn't invest in before. If you think the sort of plexiglass screens and others in building establishments, in retail establishments, are new capital, assuming they meet the definition of capital, then yes, there's some new capital emerging. There's also some types of capital that suddenly become somewhat redundant. You know, perhaps tables and chairs in restaurants if you're not allowed to sit so close together anymore, or in the extreme, maybe aircraft or football stadiums or something. We haven't made any adjustment for capital scrappage in here. It certainly seems plausible that there is some capital scrappage going on. There's not very good timely data on capital scrappage, which makes that particularly difficult to account for. But in principle, there should be a change in the composition of the capital stock. The degree to which we can really pick that up, though, is the challenge. And I think if we had perfect data, there might be no need to adjust for utilization, because it would be picked up in the investment data and the scrappage data and the capital income data, and everything would work itself out. But given that we can't, I think there is a need to do the sort of adjustment that we're doing in the short run.
Thank you, Ben. Rachel.
Hi. This is a really interesting project on capital utilization, and I was surprised, went down as little as it did. But I'm just wondering, it seems like maintenance might be a bigger deal if you're predicting will an asset be around in 2 years or 10 years than how much it's used now. And maintenance, of course, could not be just physical maintenance, but like IP, whether you sue everybody who even thinks about infringing your copyright.
Okay, so using some sort of proxy, some sort of measure of maintenance as a proxy for utilization, and assuming that when when maintenance goes up, utilization goes down. Is that what you're saying?
Yeah, if you're thinking of utilization as sort of how much of the value of the asset are you extracting now and how much are you saving for later? So you could have like occupation data, instead of the truck depreciates faster when it's driven more, the truck depreciates slower when you see all these truck mechanics working 80-hour weeks.
Yeah, that's really great. I think that's a really interesting thought. That speaks much more to me to sort of some sort of equilibrium where businesses are making decisions about how to prolong the lives of their assets and what to do with them. I think our priority has really been to think about the pandemic and the crisis, where I see a lot of this as an exogenous shock. You know, businesses didn't have any choice to stop utilizing their assets; they were forced to. So, you know, in normal times, you could maybe track utilization as hours worked of people who are there to maintain assets. But I think in the pandemic that breaks down, and it's really these other sorts of factors that are more at play. But it's certainly a really good idea and something we'll take a look at. Thank you.
It is a bit interesting, I guess, for trends over time. I sort of think about all the banks that have to employ COBOL programmers to maintain all of their old computer systems that were their software assets, that they were built in the 1970s in obscure old languages that no one can do anymore, and that I guess must be growing increasingly more costly to maintain and stop depreciating. Jonathan.
Hello, Josh. Hello, everybody. Jonathan Haskell speaking. Thanks very much, Josh. That was incredibly interesting. I think it's more of a comment than anything else. We did in work that I wanted that we did for across different countries. We looked at the thing you told us not to look at, namely energy use data. And in the UK, I think it went down by 25% in Q2, which I think is extremely close to what you get. Is that right? Am I looking at the green dotted line?
Yeah, so the green dotted line allows all the assets to vary completely. And since the largest asset is buildings, and since we're estimating buildings by the inverse of the home working rate, yes, the buildings utilization number, if we allowed it to adjust fully, would be something like a 25% drop. I don't have the exact numbers to hand, but it sounds like we're on a similar page. I guess my concern with that is that it has to be applied in a very asset or industry specific way. You know, energy utilization can't be applied as a utilization for all assets in all industries. And I could think about them. Go on.
Sorry, George. No, I absolutely, sorry to interrupt. I absolutely agree. And as I say, we were just trying to do this because we were trying to look across countries. So this was a very quick way of doing it across countries. But I think you have got much more finer grain type of results. So as you say, it's a strong limitation to the energy use. Yes, indeed. Yeah,
no, thanks, Jonathan. That's really reassuring. I think, you know, in an ideal world, we would have a wonderful suite of indicators that apply to each industry and asset with, you know, particularly good intelligence about industry X and a suitable proxy that works well in that industry, and then aggregate those all up. But we're living in an imperfect world with imperfect data, and we think that this is a good way at getting at the whole economy in a fairly consistent way that's not too demanding on the data. So that's our approach. But thanks. It is useful to know that related indicators tell a similar story, at least.
Anthony, do you want to ask your question?
Yes, thanks, Russell, and thanks, Josh. Really important stuff that you're doing. I think very useful for many of us. My question is whether you have a full utilization benchmark series. So are we somehow able to identify when capital is being overutilized versus when it's being underutilized?
Yeah, so we intentionally skirted this issue by using the ratio of usual to actual hours. And since actual hours are almost always less than usual hours, that sort of implies that utilization is always less than it could be. You know, you could have people working more hours. What you could do is put your trend line through actual hours, and then the deviations from that is your utilization change. And then you could say when actual hours are above trend, then they're being overutilized, and when it's below trend, it's being underutilized. We don't really say anything or trust very much about the levels of these utilization numbers. It's really about the change. So, you know, actual hours are 85% of usual hours. That doesn't, we're not saying that capital is utilized 85% fully. We're just using that as a baseline to get to an index figure that we can allow to change over time. But certainly you could interpret it in that way, or you could, as I say, put a trend line through actual hours and then interpret sort of over and under. I'm not sure I'm comfortable with that interpretation, but you could do it.
Yes. Yeah. Okay.
Thank you. And finally, Belen.
Okay, thank you, Josh, for that presentation. That was very inspiring. No, just a quick question, whether you have tested the impact on the MFP. I'm wondering because the capital services, well, your results prove that they are affected by this change in capital utilization, but I'm wondering which will be the ultimate impact on MFP, since the capital services enter in the growth accounts with a weight, which is, of course, below than 1. Thanks.
Yeah, thanks, Belen. And this is one of the arguments that goes with the philosophy that you shouldn't adjust for capital utilization, because it's taken care of in other parts of the framework, like a decline in the capital weight. And I think in a perfect world that might be true, but I think that the quality of our data at an industry level on a quarterly basis means that we're unlikely to see the full adjustment in the short run. The capital weight may have fallen a little. I don't think that's sufficient to account for the change in utilization that we've seen. And what we're doing here, we're not using these utilization changes to affect the capital weight. So in our official statistics, the capital weight is determined by the capital share of income, which is determined by national accounts data, gross operating surplus and the capital share of mixed income. We're not adjusting that. So we're assuming that all capital income is still capital income, whether the capital is being utilized or not. That's still the capital weight in the production function. So we're not using this to change that. And since the national accounts data hasn't changed that much in relative terms, it isn't sufficient to sort of adjust for this property. What would be the impact on multi-factor productivity? Well, we've published both estimates on this basis with the current adjustment, which is just based on that sort of more simple hours approach. But the impact is essentially proportional to the weight. So if we estimate that utilization has fallen some 20% and capital has a weight of 1/3, then we're going to have MFP. We're going to estimate an increase in MFP of 6.5% relative to the baseline where you didn't make this adjustment. So it is sort of directly proportional.
Thanks.
Okay, and well, thank you very much, Russell, for chairing, and thanks everyone for the excellent questions. That brings us to time. So thanks very much for coming along and for engaging. I think that was a really good session, a really varied session as well. So thank you to Russell and to Norahiko, the other presenters. Thank you all for coming. I hope you enjoy the rest of the conference. And I have to say before we go, I think the three of us, the presenters, will be in the discussion section, the breakout sessions in which you can access from the conference lobby for the next half an hour or so in the coffee break. So if you want to follow up the discussion, please come and find us over there. Thank you very much, everybody.